So when I look at problem 1 here, I start by asking, what would slope dude say? Marcus, what would slope dude say?
Oh, nice negative. Puff, puff, puff. Oh, puff.
Puff, puff, positive on this one. So then I know right away that I don't need to worry about putting a negative sign, that it's going to be positive, and I only need to now count the rise over the run because that's what slope is. So I'm going to draw my lines here, extending from my points to form that triangle. And we remember that our rise is the change, or not the change, the height of our triangle. So our rise is 1, 2, 3. And my run is the width. So 1, 2, 3, 4, 5. So my slope here is 3 over 5. Problem 2, I'm going to start by asking myself the same thing. What would slope dude say? Well, this is downhill. Or if he were skiing from left to right, he'd be going downhill, so he'd be saying nice negative. Wow. So now that I know it's negative, I'm going to put my negative sign down there on the slope, and I'm now going to just find my rise and my run. I do that by, again, forming my triangle. My rise is my height of the triangle, so I'm going to say the height is 1, 2, 3, 4, 5, 6, 7. It's going to be over my width of my triangle, which is 1, 2, 3, 4. So your slope is -7, 4. Problem 3, I'm finding the slope, but this time I can use 2 ways. You can use the slope formula, which is m equals y2 minus y1 over x2 minus x1, or again delta y over delta x, where we set up our t-table, or the change in y over the change in x. I'm going to show you both ways, and then from there you can determine on number 4 which way you want to use. So on number 3, my y2 is my 2 over here. These are my y values. So I'm going to say 2 minus 4 over, and my x values are here, -7 and -1. And I'm going to say -7 minus my -1 in parentheses. And I'm going to work through that. So 2 minus 4 is -2 over -7 minus -1. That changes these to positive. So -7 plus 1 is a -6. I've got my 2 negatives here, so those cancel out to positives, and 2 over 6 simplifies down to 1/3. So my slope is going to be 1/3. Now if I do this with the t-table, I'm going to set up my x and y columns, and I'm going to put my x values as -1 and -7, and my y values as 4 and 2. And then I'm going to find the change in x. So to get from -1 to -7, I'm going to have to subtract 6. And to get from 4 to 2, I'm going to have to subtract 2 again. So my change in y, my delta y is -2 over -6, which again simplifies down to 1/3. There's 2 ways to look at it. Number 4, I'm going to do the chart way. I'm going to say x and y. I'm going to put my x values and my y values. You have to make sure you line them up as the ordered pair that they're given to you in. So I have -3. To get to 2, I would have to add 5. And from 7 to -6, I would have to subtract 13. When I do this, I'm saying my delta y, my change in my y's, and my change in my x equals -13 over +5. You can do the same thing if you work through this formula right here. You'll get the same answer, just 2 different ways to look at it. So question 5 says to fill in the blank below. I will do this by finding the slope of the line, passing through the 2 points, and it gives me the points there. So I'm just going to use my slope formula up here to the left. So if I look at, I'm going to look at my 2 points here. I've got -3, -6, and 7, -6. And if you're struggling with how to set it up, you can go ahead and label them. But really, what slope is we are comparing the change in the y, or our rise, over the change in our run. So I'm going to take -6 minus -6 over 7 minus -3. And I have my double negatives there in the middle, so I'm going to change them to a positive. So when we're subtracting a negative, that becomes a positive. 2 negatives there make it a positive. We've also said boom, boom when we're doing that. We'll cross those out. And then we're left with -6 plus 6 is 0 over 7 plus 3 is 10. And when 0 is on top, that means 0 divided by 10 is 0. Now I'm going to do the same thing with my second point. So over here on the left now, I'm going to take the point 7, 8, and 7, -7, and find that slope. So I have -7 minus 8 over 7 minus 7. So I compared my y values over my x values. I get -7 minus 7, or minus 8, leaves me with a -15. Remember, we can add the opposite here to make it 2 negatives. And then that's over 7 minus 7, which is 0. Now we remember, if 0 is underneath, we're going to call that undefined. So our slope here is undefined. This would form a vertical line. I'm going to use a different method for 6, and you can also use this method on 5, but it's up to you to decide which way works best for you, and then you go from there. So this one, I'm just going to sketch these graphs. So if I'm looking at this first point here, it's 3, 7, and 3, -3. I'm going to just plot those points. I'm going to make my sketch of my coordinate plane and plot over 3, up 7, and then I'm going to go over 3, down -3, connect those 2 points, and then I'm going to say, okay, I have my vertical line here. What would slope dude say? And he would call this undefined slope. Then on 6, I'm going to sketch those points again. So if I have -4, 8, I'm going over -4, up 8. And again, this is just a rough sketch. And then if I go over 3, up 8, I'll be somewhere around there. Connect those lines, or 2 points to form that line, and I would have a slope of 0, because the slope did just tell us that this is 0 fun. Now on problem 7, it says the sugar sweet company needs to transport sugar to the market. The graph below shows the transporting cost in dollars versus the weight in sugar being transported in tons. Use the graph to answer the questions. So when I look at my graph, I notice this point right here, that's my y-intercept. When my graph starts here, my line technically would continue on this way, but when my y-intercept starts here, it tells me that no matter what my weight is down here, if I'm at 0 tons, I'm automatically going to have to pay $900. Then it goes up from there depending on how many tons you add or need to transport. So question A says, how much does the cost increase for each ton of sugar being transported? Well, at 0 it costs $900, and after 1 ton it costs $1,500. So I'm going to take my $1,500 minus my $900 to get my $600 to transport. Because then if I go from 2 to 3 tons, it goes from $1,500 to $2,100, which is an increase of $600 again. Essentially, we have just found the slope as well. I take my rise was 600, my run was 1, 600 over 1 is simplified down to 600, and that is your slope as well.